Well, it's that time of year again. We are neck deep into the 2022 Icy 3D and Toys for Tots campaign. Last year's campaign was an absolute success. Our goal was 50,000 toys for last year, and we ran over 61,000 toys that were printed by volunteers and distributed through the Toys for Tots. And this year's goal is even loftier as we shoot for 75,000 toys. Now, it's still October, and as you can see, we've still got a ways to go, but there's plenty of time to get involved if you're interested. So if you'd like to participate, head on over to IC3D's website, and under the About section, there's a section for Toys for Tots. And on the 2022 page, at the bottom of the page, there's a form that you can fill out to get involved. And these are the toys that we're printing this year. Joe Larson, the 3D printing professor, has generously donated a selection of his low poly dinos. Il3D's Train and Micro Adventure Classic trucks are back again this year. I did a video last year showing how I optimized those trucks. And we've added the McGybeer articulated alligator. Now, we got off to a little later start this year because IC3D was actually changing locations. So to keep all of the rabid elf printers happy and from tearing the place apart, they allowed us to go ahead and start working on the 2021 models from the previous year and use those this year as well. So today, the model that I'm actually going to dive into is the McGybeer Mini Octopus here. Now, this model came out in 2019 and was a huge phenomenon all over the place. You couldn't go anywhere in 3D printing and not see this thing. And even today, I think it's still just as popular. Every time I show these off, kids want one, adults want one. I also really love printing them. I mean, I really love printing these. There's about 250 of these in this picture. And as much as I love printing this is a model that a lot of people will struggle with. It's kind of intricate. It's got a lot of little pieces in there that have to sit on the build plate just right. And it can take, by default, it can take a couple hours to print one of these. But I've figured out a process that I've got these things cut way down. So let's dig in a little bit more here. First, the link on the IC3D page will take you to a Thingiverse page that you can download the model for free, or you also can get it from Printables. Now, it's important to remember this, even though this is a free model, it still has a Creative Commons non-commercial attribution license. So if we look at the files here, we can see that there are two main different layouts of this model. We have one that has the legs out straight, and we have the one that has the legs in the spiral pattern. And then you also have these two that have the sup on here, which means it's a support. And that is because the little nose on this guy sticks out and needs to be supported. Now, you can use supports in your slicing software to put one in yourself, or he's provided a version that has one in there. Honestly, the support that he has built into this model is perfect. It works totally fine. It's very efficient, and I would just recommend that you use that one. Now, there is one little gotcha with these guys. The one with the straight legs prints great. You print it, it'll pull right off the build plate. It's good to go. The spiral one, on the other hand, there's a little problem with it. Last year, when I was printing these like mad, the file that was available was version 5.6. The links of the legs, or tentacles, when you got out here to these tips, refused. See, there's a connection there. There's one there. And there's one there. And this was like this all the way around. Now, it's a little bitty small piece of material, so when you would print these, it was pretty easy to snap them all loose, but it was an extra step that you had to do when you're printing these. If you're printing 2 or 3 of these, it really wasn't that big of a deal. But last year, I printed 171 of these octopus, so it kind of got a little monotonous and tedious having to do that. So I fixed this file, and admittedly, what I did was rather insane. I went in and used a feature in PrusaSlicer where you can go in and split objects to parts and objects. So I split this into parts, which meant that it was now grouped, and each one of these little pieces now became an individual piece that I could address and look at in PrusaSlicer. And then I went in and I labeled them. The body, Tentacle 1, Part A, B, C, 10 equal 2, 10 equal 3. It took a while. I'm a little maniacal. I kind of like, to drive myself insane. Once I did this and I went through the process of going through and labeling these so I knew where they were, I was able to go in and look at these and find the little parts that I needed. And so that's 4. So 3 is this one here. And I could go in and just ever so slightly move those parts further apart so they didn't make contact with one another. And as we can see, when I slice this file, nothing touches. I'm not suggesting anybody go do this, and in fact, you don't need to do this because 2 things have changed since then. The first thing is that in June of this year, version 6 of the file was released. Now, there wasn't a lot of documentation as to what was done in version 6, and I went in and I took a look. I still saw that some of these links were fused together. Now, not all of them were. Some of them had been fixed, but I thought it was kind of odd that only a couple of them had been fixed. So I instinctively thought, I have a solution for this. So I posted my file that I went through and went crazy on as a remix on Printables. Now, why do I even bother going into all that nonsense of using the spiral version and worrying about the links and all that? Why don't I just use the straight version, which prints just fine? Well, there's a reason, of course. And when I load these up on, say, my Mini, I can only get 2 of the straight version onto the build plate at once. When I use the spiral version, I can get 4. On my MK3, I can get 5 of the straight-legged ones and 6 of the spiral versions. And when I go to my large Anycubic Predator with a 370mm diameter build plate, I can get 9 of the straight ones, but I can get 13 of the spiral versions. And when you're printing multiple versions, trying to work on production and do a large volume, being able to control the number that you can print at any one time can be a real advantage, as you can manage when you do your harvesting. And with all that out of the way, let's go ahead and dive into how I optimize this file to print. So for the heck of it, I'm using the file that I posted up on Printables. However, the steps that I'm going to go through here are exactly the same if it's the straight-legged version or the spiral version, if it's the version 6 from McGybeer or for mine, it doesn't matter. So the first thing I'm going to do just to get a baseline here is I'm going to go ahead and slice this with the 0.2mm speed profile and the stock 20% infill that it just uses by default. And we get 2 hours and 53 minutes. That's quite a while. One thing we can do is we can go ahead and kick this up to 0.25 draft mode, and then we're down to 2 hours and 20 minutes. So very first thing I'm going to do is I'm going to go up into my filament settings. I'm going to go to cooling, and I'm going to make sure that enable auto cooling is turned off. Most stock material profiles in PrusaSlicer are going to have that turned on. This Jesse PLA one is one that I've already modified and turned it off. When that's turned on, we'll see that it adds 4 minutes to the print time. And that's because when it gets up to the top of the model, it starts slowing down on the slower because your layer times are smaller. Now, when you're printing multiples of these on the build plate at once, it's not such a big deal because it can print one, move over to the next one, and the next one, and that gives that first one time to cool. So let's go ahead and start looking at the print settings on. First thing I'm going to do is I'm going to go ahead and push my layer height up to 0.28, and I'm going to put my first layer height at 0.25. I want to still get a nice contact with the build plate, but I don't want to get too crazy. And it's probably a great time for me to add in the disclaimer that the settings that I'm showing you and the techniques that I'm showing you right now are what have worked for me and the equipment that I have. Is it going to work exactly the same on your machine, even if you have a Mini? I don't know. You'll just have to try. And I didn't just immediately make all the changes that I'm going to show you in one shot and have it work magically. I started slowly making one change at a time, pushing it a little bit more, changing the layer heights, making a little setting here, see what happened, print one, see what happens, where were the failure, what didn't work, what worked, and I thought I could push even further. So it took me about a month of time to really dial in this profile to start using. And even when I come back and print this year, I've made changes this year that I didn't use last year. And I've even found that some of the changes that I've had that I'm going to show you today, I wasn't using before, and this because even the filament has changed. Different filament will behave differently. So there's my disclaimer. So I'm going to leave my perimeters at 2 for now. I'm going to leave my top and bottom layers at their default of 4 as well. You might immediately throw caution here and wonder, why am I only sticking to 2 perimeters? If you read through our documents and whatnot in the Discord for our printer else guides, you'll hear us a lot of times talking about doing 3 and 4 perimeters. And there will be parts of this model that have 3 and 4 perimeters, but let me show you something now when we slice this. The most problematic part of this model are the hinges and these pivot points in the legs. They're small, they're delicate, and if they're not printed right, they will break. But let's take a look at these. When we scroll down and through here, there's really, at their smallest point, there's not enough material or space here to get 3 perimeters into. So if we change this to 3 perimeters, it's not going to do anything for this little spot right here or this spot right here. And every one of these is like that. There might be other areas in this model that need more than 2 perimeters, but through here, this spot right here that is our key critical area, it doesn't do anything for us. So that is why I leave my default in my print settings at 2. Next thing I'm going to do here is I'm going to turn off ensure vertical shelf thickness. I hate this setting. There are times that you need it, but for the most part, it just adds extra time that you don't really need, and you're better off adding shells instead. The other thing I'm going to do is I'm going to turn off gap fills. And while it's not a big deal, in fact, let's turn that back on real quick. When I reslice and I look up here in our feature type and our timings, I actually don't see gap fill in here. And a big part of that is the addition of the Arachne engine. And the awesome thing that Arachne does is you can see kind of right here, when it comes into little areas like this, before we would have had gap fill right in here. It comes in a little smaller, and then it gets a little fatter through here to avoid having to use gap fills. This is awesome. But out of just sheer habit, I still always turn off gap fills, even though it doesn't even make a difference a lot of the time. Coming back out and looking at our slicing preview, we can see that turning off ensure vertical shelf thickness has knocked another 5 minutes off of our print time. 4 of these on a bed, that was 20 minutes. Let's keep moving down our print settings here to our infill. I'm going to turn infill off. Don't freak out. We're going to come back to that. And then our top fill pattern, you can leave it alone. It doesn't matter. All of our top patterns are curved. There's never any straight line top infills on here. But I am going to turn the bottom infill pattern to concentric. And this is really key. This is something I just kind of stumbled upon when I was making these. And I'll show you why. If we take a look at our bottom layer where we're using that concentric infill, look through here. We're going around in circles. Our main shape is already a circle. And out here, these are pretty curved too. If we didn't have concentric on, what it would do is it would do these 2 outer layers, and then it would start going back and forth through here. And what I noticed was a lot of times I would lay down that first layer and my outside perimeters would be fine. But when the head came in and started going back and forth, it would peel these little pieces up off the build plate. And when I started making them concentric and going around, it stopped pulling them off as much. Now, still every now and then it will happen. And one thing I can tell you about this model is having your first layer and your leveling dialed in is critical. You've got to have that offset perfect. And once you get it there, these just print. But if it's not, you're going to have problems. So, but doing this, putting that bottom layer of concentric infill, I found really helped. I'll ease a lot of the problems that I had with these pieces coming off in their first and second layers. If we went ahead and printed this file like it is right now, it would be a flaming disaster. You would have all kinds of holes in the tops of these legs. This up here, this isn't going to happen. But we're going to fix that. So let's keep going. Every printer is a little bit differently, but I've gotten to the point now, if I'm using a printer that has a purge line at the front or the side of the build plate, I just usually go ahead and turn the skirt off. Especially when I'm cramming a whole bunch of these onto a build plate at once, it allows me just to get a little bit further out to the edges of the build plate. Now on my Delta, it's pretty much mandatory because it's really hard to draw a purge line on a Delta. Support material isn't an issue. I'm going to skip speed for now. Although speed is super critical, we're going to come back to that and keep moving. So I'm going to go to advanced, and this is where our line widths are. Now, this model is unique in that there aren't any straight lines in it, and actually there really aren't a lot of details in it. We've got little delicate pieces in the legs and the tentacles, those joints, but they're not like details of a fine texture or something that we need to reproduce. So we can get away by bumping up all of these shells to be a lot bigger than we normally would. We've got our default extrusion. I'm going to put that at 0.5. I'm going to put my bottom layer at 0.5. We don't want to get too crazy because if we have too fat of lines, we could get some weirdness in those little thin pieces on the build plate. Our perimeters, that's going to be our internal perimeters. We can go super fat with those. 150% of your nozzle size is not a big deal. Especially if you've seen any of the videos of Tom Sandlander and whatnot that have been showing, using 0.6 millimeter nozzles with a 0.4 millimeter nozzle. No big deal. External perimeters, these are the ones that show. We can go a little fatter with them. We just want nice, smooth, clean lines, so we don't want to go crazy over extruding them. There's not a lot of infill. Well, there is going to be some infill in here. There's not a lot of solid infill. That's really the bottom layer. So the areas that we are going to have infill are actually kind of important. And normally you hear me say infill doesn't really provide a lot of strength. There is a couple key areas in this model that I'm using infill that they do. So I'm using a great big 0.6 millimeter line width on that. The other important thing here I'm going to do is I'm going to go down to my elephant foot compensation. And 0.2 normally is where I always leave it, but with these I'm going to change that to a 0.1 because we need as much surface on the build plate to hold those first layers of those little tentacle pieces down. And additionally, on this page, new now in PrusaSlicer 2.5 is where we have our Arachne perimeter generator settings. I really haven't found much need to mess with these yet. The defaults have just been improvements across the board. One of these days I'm going to dig a lot deeper in there and see exactly what I can do with these, but we can leave those alone for now. They work totally fine with this model. So now we can see we are down to 1 hour and 22 minutes. That has shaved an hour off the print time of this. But again, this model right now would be a disaster. We're going to start making some things to beef it up in areas, which is going to at first start adding some time to it. But that's all right. Let's get into it. One of the first things I did to this is, if we look on the very bottom, we've got this dome. We've got an open area, then it domes up over in the top. And when we look up in there, these blue lines mean that these are overhangs that the slicer thinks are going to be a problem. And when I first started printing these and printing them like this, this would be super ugly underneath the here. And if you've ever printed these, you've probably seen that. And I was trying to clean these up. I was shooting a heat gun in there and trying to mash down the little dangly bits. But I've got a solution to this that actually makes this a no-brainer to print now. So what I'm going to do is I'm going to go in here and I'm going to add a part. I'm going to add a cylinder because everything on this thing is round, right? And I'm going to leave my cylinder at the 20 millimeters in diameter across. But I'm going to make it 8 millimeters high. And then I'm going to place it at 0, 0 because that puts it right in the middle of my body. And then I'm going to set the height to 2. And when we look underneath of there, we'll now see that we have a flat surface. When we slice that and look inside, we can see exactly what's happening here. We get our dome that starts to come up, and then we go into bridging. Now, this is not that big of an area here, right? The dome that we put in, or the cylinder that we put in there was only 20 millimeters across. Most printers can bridge this area no problem at all. And if we'll notice, we don't have any more of those blue rings that are an overhang problem underneath. So when I started doing this, the bottoms of these, perfect. No problems whatsoever. Even when I had my old Ender, it could do these. While this fixes one problem, it actually introduces another problem. And we're going to address that here in just a minute. But before that, because we reduced the elephant foot compensation down to 0.1 millimeter, sometimes I would notice that I would get just a little bit of a sharp edge right here because the elephant foot compensation wasn't able to do its job. So there's one other little modification I made right in here. And what I did for that is I added like a little chamfer here. Now, easy to do if you're in something like Fusion 360. A little bit more tricky to do when we're in the slicer. And the way I got that solved is I went in here and I added another part. But I added a negative sphere. And I made this sphere 24 millimeters in diameter. And like the cylinder, put it right in the middle. And then I brought it down to a negative 23.5. And if we look in here, we can see there's a little bit of an area that it overlaps. And we can see now that we've got a little area right in here where it starts to slope inward. You can see it again here as it builds here. It's a little bit smaller in there. And that was one way that I was able to compensate for the fact that I didn't have the elephant foot compensation. And sometimes you might get a few little sharp pieces on the ends of these tentacles in here, you know, right up in here, but they aren't really going to be a problem for a kid. But a sharp edge right in here, that's a problem. And we've got a contour or a bevel leading outward, sloping outward here on the outside of the body. So that's not really a problem. I've never had a problem there. It's this area right here where it went straight up. Sometimes there'd be just a little bit of a sharp edge. And by dropping that ball up in there as a negative and putting that little bit of a curve in there, a chamfer, I was able to take care of that. Now what we're going to start doing is we're going to start targeting our different layer heights. And when I do that, one of the things we're going to do is we're going to start adding in more perimeters. And I can tell you from experience that the areas that I've had problems with are like the tops of these little tentacle areas. I would get, depending on the filament I was using, I would get little holes right up in here, especially out on these tips here. There's a hollow spot underneath there. And even though it shows these layers lining up on top of each other, depending on the filament, I get little holes in the tips of their toes. And then likewise, right up in here on these little crest areas above where they attach, depending on the filament, I would get little gaps in there. And because we want the absolute best looking and strongest toys that we can, that's a problem that needs to be addressed. The way I do that is, let's just go back to our slice preview. I'm going to drag down, and I found that right about 3 millimeters off the build plate was where I'd start. And we're past, you know, a lot of these areas here. We don't really need anything in there, like I said before, but we do kind of need it here. And if I start at 3 millimeters, and then I would go up to about 10, and that would get me the tops. That would get me the tops of these little areas up here. So what I would come over and right click on my Octopus, I think getting back to this preview, right click, and I would go to height range modifier. And I would have the start at 3 and end at 10. Now, when we scroll out and we look, we can see this is the area that we are looking at right in here. And what I'm going to do is I'm just going to add perimeters, and we're going to make that 3. Now, I'm not changing these, so I actually can just delete those. Could have also gone into settings and added a perimeter here, and then I could hit everything individually. It's just a little quicker to do it that way. And now we'll see our toes have 3 perimeters right there. And in through here. And see, we didn't add anything here. It didn't do us any good there. But it did here and here. And that just allows that to build up on there. And that fills in that top area. And when I started doing that, it took care of all those little holes I had. And it also took care of all the little gaps and things that I would have up in here. Now, again, maybe you won't need to do that. Maybe your printer works a little bit differently. Maybe your material behaves a little bit differently. Not every material I used required this, but enough of it did that I just made that my default. Remember when I talked about this cap being a problem? The issue is while it looks great down here, there's nothing really holding it on. And what I found was if I put any pressure at all on the base of here, this little flat piece would just pop off and roll around inside of the octopus's head. and that's no good. So what I did to fix that is I went in and I added, if I click over here on my layers, I could click on here and add another height range modifier, but all I have to do is click over on my layers and hit plus, and it's going to give me another range to work with. If we look at our cap area, we can see that it starts right about 14.5. So if we come on down to say 13.5, we can get underneath of it a little bit, and then we can go on up from there. So we're going to make this be a 13, and we'll say 18. And then now that we have that, we can come in here and we can add infill. And what I found was that if I did 5% triangles, that would start out and put this great perfect little crisscross pattern over the top of that where it's focused in the center. And it would start below, anchor in nicely, give a little bit of a platform for that cap to sit on top of, and then collapse it or encase it all in there and give it a nice anchor into the side. Now, I've also said that most of the time our strength is in our outer perimeters, not necessarily in our infill. I found with this model, at one point in time, I was doing more perimeters all the way through here, like 3 perimeters all the way, or most of the way up, and no infill. But depending on the filament I used, if the filament was at all transparent, I'd get a different surface texture in those different areas. Ultimately, I decided to go ahead and run the infill all the way to the top, which this thing's like 34 millimeters high, just so that the exterior appearance was a little bit more appealing. That's all locked in. We've got nice infill. It does give us a little bit of lateral support in here, so you're less likely to crush his head from the side, which is what we also would get by adding more perimeters. And again, like I said, this for me, this was a good trade-off because I was using a lot of transparent filament. If you're using totally opaque filament, you could use 3 or 4 perimeters in here instead of this infill, and it'd probably be a wash. But by doing it this way, I can use whatever filament I want and not worry about it. So the next thing I'm going to take a look at is as I get higher up to about 26 millimeters or so. Down and through here, our sides are pretty straight, but when we get up to about 26 millimeters, we start to cave over. And the reason we can tell that we need to address that right now is we can see that the slicer's starting to put in this stuff right here. And even though we said turn off vertical shell thickness, because we're using infill, it automatically goes in and puts it in anyway. And remember, when we didn't have any infill turned on before, this wasn't here. The way to take care of that is we give it enough perimeters that it doesn't care. So we can come back to our layer and we can add in another layer. And we're going to start at 26, 28, 26 to 28. And then we're going to add a perimeter where we don't need to worry about top and bottom. We're going to add a third perimeter, and we're not going to delete it. And nothing happened. Well, why? Why did nothing happen? I'm not sure if this is a bug or if it's a feature, but what I have discovered, for whatever reason, PrusaSlicer doesn't seem to like for its layers, when we're doing the height range modifier here, to overlap. So if we go back to our first one here, and we change this 34 to a 26. So now we go 13 to 26, 26 to 28. We'll see that we picked up our third perimeter, but we also lost our infill. What we have to do then is we have to go in and we have to also add in the infill and the perimeters to that area. And then we'll see now that we have both the perimeters and the infill. And what I found was that when I got into those areas where I had like the infill, right, and it started putting in this stuff anyway, it's a lot more efficient to put in the perimeters than it is to let it do this zigzaggy stuff. What I found worked out really well was I went in and I added 2 more ranges. So I did 26 to 28, 28 to 30, 30 to 33, All right, so we've got this area, this area, this area, and this area. I guess I can go ahead and make that 34. It's actually not going to make any difference because we're already doing so much infill up in there. So what I'm going to do here is I'm going to real quickly go in here and add all that in here. And now we'll see, as we get in there, we've got infill in here, right? But we're not getting any of that little blue back and forth stuff until we get way up to the top. And once we get up to the top right here, it's only a couple layers, and I found that that's actually totally fine right there. We're not adding any more perimeters until we need them, but there's one other little trick that I do in here also. If we come down here and we look at our layer progress, we'll see how this prints. It's going to print the innermost perimeter, and then it's going to print the outermost perimeter. In this particular case, it's going to be fine because we've got our infill. But one thing I'll do sometimes, if I don't have a lot of infill or I don't want to put infill in a particular area, I'll actually change the order so it does the outer perimeter first, and then it starts doing the inner perimeters. So I can show you what that looks like here. Turn that on. And now what we're going to see is it's going to start with the outer perimeter, and it's going to build all the inner perimeters from the outside in. And what that does is when it's building this inner perimeter, it has something to hang on to on the perimeter right next to it. Whereas when we go into an area where we don't have that turned on, it starts on the very inside first. And in this case, we're sitting on top or close to on top of another layer, and we have infill. But if you have any problems in there, that's another thing, a little trick you can do is once you get onto a curved surface where it starts to curve back onto itself, flip your perimeter order. Start on the outside and work your way in. So I'm going to go ahead and quickly make that change to these. We now have a very solid octopus. We've got our first layer that's concentric, so we have our best possible adhesion. We get our extra little layer right here to help out with the tops of our tentacles and that little contact point. We've got our dome capped off so we don't have any scragglies hanging out underneath, and it is properly secured. And as we get up to more and more overhangs, as we curve back in ourselves, we get stronger and stronger, starting with the outside and working our way in. Now there's two more things I'm going to do here before we start and go back to the speed. If you look real closely, you can see this line right here. That is where PrusaSlicer wants to put our seam, right down the front of this guy. He's going to look like he's got a scar running across his face. We could do a couple different things with that. We could go in and we could move our seam to be random, or the rear, or nearest. Well, nearest isn't going to do us any good because it's a circle. Random means it's probably going to look like he's got acne and pimples all over him. Rear should put the seam towards the back of the build plate, but if you have to do any rotations on these, it could get weird, and it isn't always perfect. So what I like to do is go ahead and come in here to our seam painting tool, and I'll just change our brush size down a little bit, and I'm just going to run a seam right down the back of this guy. So rather than looking like he's got a scar on the front of his face, he's going to look like he's got a zipper down the back. And when we're thinking about a toy, if we're going to have a blemish or anything like that, let's have it on the back, because people aren't staring at the back of this guy's head. They're looking at his cute little face. One more quality thing I'm going to do here. I'm going to come up here to the variable layer heights. And right now, we're using 0.28 layer height all the way through this guy. When we get into extreme areas here, where we're coming back on there, we can get a real definite stair-stepping effect. And what we can do is we can use the variable layer tool, and we can come up in here and we can smooth that out a little bit. And we'll take that, say, like to 18. And we'll say right about in here's where we want to feather out. So I'm just going to kind of add, click, I'm left clicking in this area. You can see down here, here's your instructions. I'm left clicking to kind of build this ramp out kind of semi-straight. And then what I can do is hold down the shift key and hit the right mouse button and just drag across there. And what that does then is it says down here is that smooths it. So we get kind of a nice even ramp on there. Because what happens is if we had it real abrupt, you would see a line in the side of here where the layers were different heights. And with that little bit of a ramp, we can see, we can't really see any marked area here that looks really different, but we can tell at the top here, it's not quite as drastic as it was before. So that now has us at 1 hour, 37 minutes. So we added back on some time, but we are still 45 minutes below where we're at. And that takes care of all the modifications that I make to the model and the changes and the heights and everything. Now we're going to go look at speed. This is another area that's going to be very dependent on the material you're using and the printer you're using. PETG doesn't usually like to go as fast as PLA. ABS, if you've got a machine that can handle it, can go extremely fast. If you've got a V-slot machine like an Ender, it's not going to go as fast as a machine like a Prusa or a Kaiwu that has linear rods, and they're not going to go as fast as a machine that has linear rails. So for me, through trial and error, by starting with these basic settings here that are built in that are very conservative, even though this is the draft profile, or sometimes Prusa calls them the speed profile, they're still very safe, sane, conservative settings. So when I got to these settings that I'm about to show you, I worked up to them. I started with like my internal perimeters here, and I went up 10. Ultimately, I found I could get up to 85 pretty reliably. These small perimeters, that's going to be down where your little tentacle feet are. I was able to push those to 50. And again, I worked up slowly on those. My external perimeters, I pushed to 65 because I still do want a nice surface finish. Infill and solid infill at 100, that is still pretty screaming. That is one area where Prusa will get a little bit more aggressive with. My top solid infill, there really isn't a lot of top solid infill on there. It's more like top perimeters. But I usually, on all my prints, make that 55 anyway. Support material, we don't have any support material. Bridges, the only place we really have bridging is the area over that cap that we put in. You know, we could take that to 45 because that's a small little area. Gap fill, we don't have any. We don't have to worry about that. Now, first layer speed. If you've got a machine that's having issues with those little tentacles staying stuck down, drop your first layer speed down. Drop it down to 10 if you have to. That's fine. Now I can push this to 25. The other good thing to look at here is acceleration. Now I'm not going to get deep into acceleration, how to find the right settings, and there's all kinds of holy wars about Clipper and blah, blah, blah that you can do with acceleration. But what acceleration is how quickly does the printer go from a dead standstill to its full speed of, say, for example, 85 millimeters a second. It can't do it instantly. It's got to ramp up to it. Now, the longer the distance it has to ramp up, you know, you're not going to get ringing and whatnot in your prints. If you try to go too fast, you can get artifacts. I have even seen if you take off too fast, your extruder can't keep up and you can have gaps and holes in your prints. Prusa has started pretty conservative with these values, and I have found that 1500, 2000, 1000, you know, bridging, it's like there's hardly any bridging I didn't worry about, so I didn't even bother with it. And 2000 for my first layer. And then 1500 for my default, which is like anything doesn't fall into there. Those are good areas that this machine can hit and still provide me really good results. Can your machine do that? I don't know. If it's got V-slot wheels, maybe not. If it's got linear rails, yeah, probably sir. If it's a Core XY, it could probably blow those away. One thing I can tell you is that nothing in these settings right here, all these print settings right here, are specific really to Prusa. They are very generic settings. They will work on pretty much any printer. So you could start with the base settings that Prusa has set up for one of their printers. If PrusaSlicer doesn't have your printer listed in it when you install it and set it up, and you probably are going to be okay. The one thing you're going to make sure is make sure that your printer settings, which are machine specific, are appropriate for your machine. And if your manufacturer has provided you those settings or it gave you a Cura profile, it's pretty easy to go in, pull those settings out, and put them in over here. So now for our grand reveal, let's see what our time is now. 1 hour, 17 minutes. Not bad. We still shaved about an hour off of there. I mentioned earlier that we actually could go to 0.3 millimeter layer heights. Let's see what that does for our time. We'll go ahead and change this to a 0.3. And it didn't change anything. Well, that doesn't seem right, does it? No, it's not. And it's not right. Here's why. When we went in and we did our height range modifier, it locks in the layer heights for the whole model, not just the area that we did here. So these areas down in through here that we want to be 0.3 are locked at 0.28. So to fix that, what we do is we use the right mouse button, which is removes detail, and we click through here and we just drag, and we can see all those areas now are getting changed to 0.3 millimeters. Now let's see what we get. 1 hour, 13 minutes. We pretty much cut our print time in half. Again, I can't stress enough. Can your printer do this? I don't know, but maybe. And the only way you'll find out is by slowly going in, making those changes a little bit at a time. Now, most of the changes I did in here as far as infill and the height ranges, you're good to go. The biggies that you're going to want to sneak up on are going to be your speeds. The photos that I showed earlier and the ones you're looking at right now, they are using the settings that I just showed you. These 200 and some odd toys that I'm showing you in this box were all printed on my Prusa MK3 and my Prusa Mini using almost exactly these same settings. I hope you found this video informative and even learned something. Just remember, there are no magic profiles. Every model, machine, and material has its own unique requirements for an ideal print. And that isn't to say these settings are ideal. Do you have something that you would do different? I'd be happy to hear about it in the comments. There's still plenty of time right now at the end of October 2022 to jump in on the 2022 3D Printing Toys for Tots campaign. We welcome anyone that is devoted to producing great prints to bring a little extra joy to a child this Christmas. Are you already involved with our campaign and have a question about one of the other toys? Let me know. Maybe I can dig into that one as well. Thank you all, and I hope each and every one of you has a blessed Christmas this year.